we know that if there's nowhere for the pump's flow to travel to, it will trigger the pressure compensator and move the pump off stroke. When that blockage is gone, the pump will attempt to move back to the maximum displacement angle. But what if we install on the pump outlet line some type of throttling valve that allows us to intentionally control the speed of a hydraulic motor or a hydraulic cylinder? We're going to leave this throttling valve open partially at all times to examine what happens next. Now, we need to assume that the pump has been deliberately oversized, which is quite typical. And so with these assumptions, let's see what happens. As the pump swash plate moves towards maximum displacement, we find out that it cannot reach that value. The throttling valve is not open wide enough. So the pressure between the pump outlet and the throttling valve hits the maximum value as determined by the setting on the compensator spring, and the pressure compensator spool moves, and we send outlet oil down into the control piston to start moving the pump off stroke. But because we're still consuming flow into the hydraulic system, pressure falls very quickly, and the pressure compensator spool closes once again, and the bias piston brings our pump back on stroke. So in both of these cases, we neither reach the zero angle fully off stroke, nor do we reach the maximum angle for maximum displacement, which in many pump models is around the 20-degree mark. With our throttling valve left in the partially open position to control the speed of a cylinder or motor, we may find out that this pump is now moving its swash plate back and forth between, say, 10 and 11 degrees. And the compensator spool is popping open and shut. The control piston and the bias piston are doing their job, and our swash plate is moving through a very small angle. If we were to look at a pressure gauge on the outlet line, we'll find out that we really can't see any variance in pressure. It's too small. If we were to look at the flow rate, we'll find out that the flow rate is actually quite smooth. And so this is how the pressure compensated pump can achieve a constant pressure function and still provide only the flow rate necessary as called for by the throttling valve in the system. I hope that helps. Thanks for watching.